Okay, so good morning, and we are going to hold, no, or have. We're going to have our new lesson. No? So our new lesson will be motion in. Okay, let's just change the color of our font. No? So let's have now motion in a straight line. No? Maybe in your text, no, this is motion in one dimension. So basically, now this will involve straight line motions, or they call it rectilinear motion. So rectilinear motion, rectilinear motion, no, is a motion along a straight line. No? Now we are going to consider motions in a straight line only, no? Because it's kind of complicated now when we deal with motions that are already turning. No? So may arang, we have what we call curvy linear. No? And again, this will involve turning motions, no? Objects that goes round in a certain direction in a circular path, no? Like the revolution of a planet. No? So planets go around the sun, or satellites like the moon goes around the earth. No? So these are other types of motion. Now, what we are considering are simply straight line motions. No? And primarily, no, we are going to focus more, no, into a type of motion that is what we call, no, kinematics, or this is a study. This is the study in physics where we deal with motions. So this is a study of motion, but does not, no, include, again, no, kinematics is a kind of a study, no, study of motion without considering, no, the effect or the result of a force. No? We realize that a force will always, no, create motion. No? And motions, again, no, resulting from the actions of forces will cause the force either to stop moving kung nagahulag na siya, no? Or if it is not moving, then it will cause the object to accelerate or move forward. No? These are, again, no, several effects of forces. No? Some forces could also create this turning motion. If you twist, no, the cap of a bottle, no, ang taklo balas ang inyo Coke, no, you can apply a force there, and then you can twist it. We call the twisting force there as torsion. No? So varied types of forces, guys. No? So we've learned, we are going to encounter probably tension. No? That's one kind of a force. Compression, and you have your torsion. Torsion, again, no, is a kind of a force that is moving in two opposite directions. No? Now again, if you are going to go into engineering someday, no, you'll realize that these forces, no, are occurring in a structure, in a kind of a building, and if torsion will twist a building, it can also cut or create, no, a collapse of the building. No? So when you eventually study these forces, no, you'll realize that they have some effects on structures, on the integrity, no, of how strong is your building. No? But then again, now we will disregard these different forces first, no? And we will just study motion as merely motion. No? There's a car, for example, no, a car that is moving. So we will not consider so if the car will now make a turn, no, like if you are in the flagpole area of CPU, you'll realize that the car there now will turn around the rotunda. So that's not a straight line motion anymore. No? So ang aton i-consider lang, we will just narrow it down into a car that is running on a straight road. No? If it's a road, no? We will not consider the time that it will go around a rotunda. If ever it will make a turn, then it has to make a turn, no? In a kind of a street nga tadlong man ang yakilid, no? So, but we realize that in between, no, when it makes a turn, no, something happens to its motion, no. So again, no, a car moving in a straight line, no. So amula na, no, we will narrow it down, no. We are going to divide, no, the three types of motion, no? So you'll realize that when cars travel, no, they undergo three types of motion. And the very first one, no, is what they call as uniform motion. No? The next one, probably now you can have the uniformly accelerated. And then the third one is simply accelerated motion. No? Now, how will we distinguish one from the other? No? How will we know one from the other? No? Now, let's try to consider the first type, no? The first one. No? So let's go into uniform motion first. No? How will we know that a vehicle na is running or is undergoing uniform motion? No? So let me illustrate that now, for example, by showing a certain diagram. If you're going to divide this, no? So let's say I'm going to slice this. Now, in each of the interval here, now let's say I'm going to label it. No? So this is point A. No? This is next your point B. Next your point C. D. E. No? And then somewhere at the end, you'll have your point F. No? So we have your points A, B, C, D, E, F, and then just below that, no, we will have no the certain distance. Let's say the distance here is 3 meters, no. So each of the interval there is 3 meters each. And then for each of these intervals, let's say the time it takes, no, the time it takes for the vehicle there to move is it takes 1 second each, no. So question, we are going to encounter the term eventually, no, that we are going to call as velocity. No? Now this term velocity, no, or speed, guys, no, how do you get the velocity of the vehicle there? No? So since the vehicle is moving from my left to right, no, so we can consider that as a velocity. No? So this one is simply one straight motion from my left to the right, no, and it's moving in these intervals. Now, if you're going to get the velocity of this vehicle, how do we get the velocity? So first of all, now we are going to get its displacement, and then we divide it with the corresponding time. So displacement over time gives you your value velocity. Now sometimes they simply write that with a value v. And then they equate it now with a certain displacement S. And again, now the symbol that they use for displacement is letter S. No? And then they divide it with some unit of time, T. No? Now, usually, pila karon ang aton ang aton nga velocity, guys. No? Pila aton velocity karon, no? So, let's say now the first velocity, we are going to call it as V sub 1. No? Ang V sub 1, the V sub 1 value is the velocity, no, from A to B. Pila ang velocity sa A to B? Distance over time, no? Pila yung velocity? That's 3 meters per second, no? How about V sub 2?
3 meters mo, sir.
So, velocity is a value, no, nga per unit of time. No? So, anong velocity number 2? Velocity number 2, supposing is from B to C. What's our velocity number 2?
3 meters per second.
Meters per second, mangyapon, no? V3 is still
3 meters per second, sir.
ang aton V sub 3 is still, no, 3 meters, no, per second. And what do you realize with our velocities? The velocity in this case, now if you're going to, it's always a constant. No? So K is a constant. No? So you'll realize that if we are going to describe, no, a uniform motion, no, so uniform motion happens, no, when, no, the object, no, is traveling at what? At a constant velocity. No? So again, no, we can describe uniform motion as what? It's a motion, no, that where again, no, the implication is, no, V is eventually a constant. No? There are two things that are constant there. Huh? The speed and at the same time, its direction. No? So if the velocity is constant, then we can consider that as uniform motion. No? Okay, now my question is always like this. Can we always sustain, no, the body can travel, no, with such uniform motion? No? Let's say if you're traveling from Iloilo City to Antique, can you literally say that you can travel with uniform motion? No, I don't think so. No? No? When you first get into the bus or into the ano na ba lang, mga van, no? Say you are commuting, it's impossible that the van is already moving, di ba? Just imagine, no? You're riding a jeepney and the jeepney is already moving, no? Can you imagine that? Now, when you reach your destination in CPU, the jeepney driver will just tell you, okay, you're prepared to jump, no? Because this is a car that is moving with uniform motion, so you cannot stop, no? Imagine yourself jumping out of the jeepney, no? Okay. Again, no? Every time that the jeepney driver will pick up a passenger, it has to stop. Every time it has to drop a passenger, it has to stop. No? So uniform motion is something that is quite impossible to occur. No? Okay. So, but anyway, amula ni Anay, now we will just introduce the very first type of motion because we have less than a minute already to go. No? And any question?
Wala, sir.
I'm going to give you as an assignment our number 2 and number 3 types of motion. Okay, so